Good morning, students. Students, today we will start a new chapter, Sources of Energy. In this chapter, we will read conventional and non-conventional sources of energy about fossil fuels, thermal power plants, hydropower plants, wind energy, biomass, solar energy, energy generated from sea, geothermal energy and nuclear energy, and their effects on our daily life. We use energy for all our day to day activities. Then naturally a question arises, what would happen if there is no energy? If there is no energy, we shall not be able to cook food, light up our houses during night time with electricity, using various electrical gadgets and appliances which uses many types of energies such as electrical energy, thermal energy. Our transports uses petroleum products, chemical energy. Thus energy is essential for our survival. Let us take a simple example. If we light a wax candle, the chemical energy in the wax is converted to heat energy and light energy on burning. However, if we somehow put together heat energy and light energy together, along with the gases produced during this burning of candle, we cannot generate back that chemical energy in form of wax. This shows that during burning of candle, the energy in the usable form, which was chemical energy, is being dissipated to the surrounding in less usable forms, which is heat energy and light energy. Any source of energy we use to do work is consumed and cannot be used again. So, what should be a good source of energy? A source of energy is one which can provide sufficient amount of energy in a convenient form for sustained use over a long period of time. एक ऐसा सोर्स जो बहुत ज़्यादा अमाउंट में एनर्जी प्रोवाइड करे, कन्वीनियंट हो, जिसे कंट्रोल किया जा सके, जो लंबे समय तक चले, उसको हम कहेंगे गुड सोर्स ऑफ एनर्जी. और हमारा अल्टीमेट सोर्स ऑफ एनर्जी कौन सा है? आपने लोअर क्लासेस में भी पढ़ा है, इट इज़ सन. सो द चॉइस ऑफ फ्यूल comes here. Choice of fuel, the choice of particular fuel or a source of energy selected for performing some work depends upon some factors. So here are the characteristics of good fuel. Amount of heat energy released by the given fuel on burning. First factor on which a good fuel depends. So what should be the amount of heat energy released? It should be sufficient enough to do some work. The rate of release of heat by given fuel on burning. फ्यूल जलना भी चाहिए और तेज़ी से जलना चाहिए. द क्वांटिटी ऑफ स्मोक प्रोड्यूस्ड, यानी एनवायरनमेंट को लेस पोल्यूटेंट होना चाहिए वो फ्यूल. द इजी अवेलेबिलिटी ऑफ द फ्यूल, इजीली अवेलेबल हो. कन्वीनियंस इन स्टोरिंग एंड ट्रांसपोर्टिंग ऑफ फ्यूल. द प्राइस एट विच फ्यूल इज़ अवेलेबल एंड फॉर व्हाट पर्पस वी नीड द फ्यूल. अगर आपको खाना पकाना है, you wish to cook food, you may be using wood or you may be using LPG gas. So which one is better? LPG gas is better for cooking, as if less amount of smoke is produced, more amount of heat is generated by burning fuel, it is easily available, convenient to store and transport. So we consider a source of energy to be a good source if and only if it does provide a large amount of work per unit mass or volume, that is large amount of heat per unit mass or volume when the fuel is burnt. Mass in case of solid fuels and volume in case of liquid fuels. Second, it is easily available at economical rate. Third point, it is easy to store and transport. Fourth, it is safe to handle and use. Fifth, it causes no or least possible pollution. So it should be safe to our environment. So now, what are the sources of energy? There are two sources of energy, conventional and non-conventional. Conventional are wood, hydro, that is water, and fossil fuels. Fossil fuels such as coal, petroleum, natural gas. Non-conventional sources of energy are solar energy, wind energy, biomass, tidal energy, wave energy, and ocean thermal energy. All comes under ocean energy, and geothermal energy, and last one is nuclear energy. So these are bases on conventional and non-conventional. Another type, if you classify the sources of energy, you can classify them in renewable sources of energy and non-renewable sources of energy. Renewable sources of energy are those natural resources which can be regenerated as we use them. For example, solar energy, wind energy, biomass, ocean energy, geothermal energy. Second one is non-renewable sources of energy. Non-renewable sources of energy are those whose rivers in nature are limited and which cannot be regenerated again and again. Thus, these energy resources are exhaustible and cannot be used to produce energy again and again and for a long period of time, such as fossil fuels. Your coal, your petroleum, natural gas are the example of non-renewable sources of energy. And conventional sources of energy are the traditional sources of energy, which are being used for centuries by common people to fill their needs of energy. Now coming to fossil fuels. Fossil fuels are natural fuels which were formed deep under the earth's surface from the prehistoric remains of living organisms like plants and animals. If you are talking about coal, it should be the fossils of plants, and if you are talking about petroleum and natural gas, it is the dead remains of animals. Coal and petroleum natural gases are example of fossil fuels. At present, the demand of energy is large and it is mostly met by fossil fuels. In India, our country, about 75% of energy which we are today demanding is fulfilled by the use of fossil fuels. No doubt, we all are generating technologies to switch over to non-conventional sources of energy such as solar, wind, hydro energy. Now, how these fossil fuels were generated? These fossil fuels were formed millions of years ago when plants and dead animals were gradually buried deep into the earth. And slowly and gradually, these were converted with sediments like mud and sand. They were covered and converted into the fuels in absence of oxygen and under high pressure and temperature. It is believed that the buried remains of plants were converted into coal reserves and the remains of animals were converted into petroleum and natural gas. Now, what are the common fossil fuels? Your coal, petroleum, and natural gas. First, we consider coal. Coal is a complex mixture of compounds of carbon, hydrogen, and oxygen. Small amount of nitrogen and sulfur compounds are also present in coal. The percentage of coal present in sample of a coal is a measure of its quality. When coal is heated in the absence of air, that is, in the absence of oxygen, all the volatile material is removed from the coal and coke is formed. As coke is about 98% of carbon, it is a much better fuel than coal. The calorific value of coke is high and it does not produce smoke on burning. Now petroleum, the second fossil fuel. Petroleum, its another name is crude oil. It is a dark colored, viscous and foul smelling oily substance which is found under the earth crust trapped in rocks. The crude petroleum is a complex mixture of several solids, liquids, as well as gases, mixed with water, salt, and other earthy particles. Crude oil obtained from oil well is first washed in oil refineries with acidic and basic solutions and then subjected to fractional distillation. The fractions obtained as a result of fractional distillations are generally petroleum, which is also known as gasoline, kerosene oil, diesel, lubricating oil, paraffin wax, asphalt, etc. Calorific value of petroleum product is very high and no residue in form of ash or something else solid substance is left behind on their burning. The third one is natural gas. Natural gas is generally found with petroleum in oil wells. Some oil wells yield only natural gas. Natural gas is a fossil fuel which mainly contains methane gas with small quantities of ethane and propane. 95% of it is methane gas. When this natural gas is highly compressed, it is also known as compressed natural gas, that is CNG. Now, what are the disadvantages of these fossil fuels? Three fossil fuels: coal, petroleum products, and natural gas. When burnt, they produces smoke and they pollute air. Burning of fossil fuel produces acidic gases like sulfur dioxide and nitrogen dioxide, which gradually when mixes with rainwater produces acid rain naturally, which is harmful for our monuments and buildings. Carbon dioxide, when produced by the burning of fossil fuels, is responsible for global warming. The burning of fossil fuels also produces carbon monoxide, which is poisonous in nature, and when mixed with human blood, with hemoglobin, it reacts and forms carboxyhemoglobin, which is a stable element and which even causes death. And burning of coal, which is a fossil fuel, leaves behind ash, which is also known as fly ash because it is very light in weight and very fine particles of it are produced, and which results in diseases like asthma and other respiratory diseases. Now here are few pictures. First one is greenhouse effect. The chemicals which are burned, the fossil fuels which are burned, produces high amount of sulfur dioxide and nitrogen dioxide, which mixes with rainwater and produces acid rain. Moreover, carbon dioxide released by the burning of these fossil fuels produces greenhouse effect by trapping the radiations reflected by the earth. As you can see, the color of Taj Mahal is turning to yellow, it's turning palish rather than white. It is now palish in color. It is due to acid rain. Moreover, the global warming is also resulting in the melting of our glaciers and icebergs. Now, what is a thermal power plant? Thermal power plant is an installation in which a fossil fuel is burned to produce heat, and this heat energy is converted into electrical energy. In commercial power plants, there is a turbine to rotate the shaft of dynamo. Let me show you the figure. Here is the thermal power plant in which here the black substance, that is coal, which is used to heat up the water in the boiler, and when this flowing water is heated up, it converts into steam and rotates turbine, which is connected to shaft of a dynamo. And this dynamo is electrical generator which generates power. So this mechanical energy, which is a rotatory energy, the rotation of shaft, is converted into electrical energy. The simplest turbine has only one moving part known as rotor blade. This turbine rotor blade, these blades are pushed by high pressure steam. When these blades rotate, this turbine is connected to the shaft and gradually to the dynamo, your electrical generator. When this blade moves, the shaft moves, and your generator starts producing power. In a thermal power plant, large amount of fossil fuel is burnt to heat up water to produce steam. This steam runs the turbine to generate electricity. Okay, now the second one is hydropower plant. In hydropower plant, water is stored in form of reservoirs with the help of dams. Hydro energy is the kinetic energy of flowing water in a narrow stream which converts the mechanical energy into electrical energy. How mechanical energy? As the blades on the turbine, when the high pressure flowing water strikes those blades, it rotates the blade, rotates the shaft, and finally the dynamo, the electric generator, rotates and produces power. The hydro energy is the potential energy of water stored at a height. पानी जितना ज़्यादा क्वांटिटी में और जितनी हाइट तक होगा एक रिजर्वोयर में, एक डैम में, उतने ही ज़्यादा प्रेशर से वो फ्लो करेगा, एंड हेंस इट कैन रोटेट अ huge turbine producing electricity. Now how it works? High raised dam is constructed on a river at a suitable location to obstruct the flow of water and thereby resulting collection of water. This water level rises in this dam and thus stores potential energy. Sluice gates are constructed at the bases of the dam. When these gates are opened, water from the high level in the dam is pushed through this channel, or you may say pipes, to the turbine. The turbine of the electric generator installed at the bottom of the dam. Now the potential energy, which has been converted into kinetic energy of water coming through this channel, moves the turbine. As a result, electrical energy is generated and it is transmitted through power lines. Now coming to the advantages of hydroelectricity. It is a renewable source of energy. No fuel cost fossil fuel is burnt. Fuel cost is low. Floods can be controlled. This extra water which is stored in dam is channeled through canals used for irrigation. But what are the limitations of hydropower energy? The installation cost is very high. No doubt running cost is low, but installation cost is very high. A large land area is submerged under water, which is now not useful for vegetation and also produces methane gas, which ultimately responsible for greenhouse effect. It also causes displacement of people at a large scale which were inhabitant of that land. The next renewable is, here is the diagram of hydropower energy. How a reservoir containing water, when sluice gate is opened, then the water is channelized through a pipe to the turbine, and generator when rotates with help of turbine produces power, which is further transmitted to the houses. Next one is biomass energy. The biomass energy is the waste material, the biogas which is produced by waste material, that is decomposition of animal dung and other bio waste in the absence of oxygen. Biogas is a mixture of methane, carbon dioxide, hydrogen sulfide gas, and mainly the constituent of it is methane, which is about 75%. The biogas plant is also known as gobar gas plant. Biogas is produced in a biogas plant. The plant has a dome-like structure built with bricks. Let me show you the diagram. Here is the diagram. Built with bricks. The slurry of cow dung and water is mixed in this tank. Then this slurry is fed into the underground digester tank, which is U-shaped, as you can see in the figure. The digester tank is a sealed chamber in which there is no oxygen present. Inside this digester, anaerobic microorganisms which do not require oxygen to decompose, they decompose and break down complex compounds of cow dung slurry, other bio-waste products such as your vegetable peels, your plants, leaves, etc. The decomposition process takes place. It takes a few days to complete, and as a result of this decomposition, biogas is generated. The biogas is stored in the gas above this digester. From this gas tank, outlet of biogas, as you can see with the help of gas valve, outlet of biogas is there from which it can be used for cooking and for other heating purposes. The removed slurry is an excellent manure which is rich in nitrogen and phosphorus and can be used as a fertilizer. There are many advantages of biogas. It is an excellent fuel which contains 75% of methane, leaves no residue behind. It burns without smoke. It is having high calorific value. Biogas is odorless. It can be used for lighting, heating, generating electricity and cooking. And the slurry produced in a biogas, which is the byproduct, is used as an excellent manure which is rich in nitrogen and phosphorus. In biogas plant, there is a large-scale utilization of bio-waste and sewage material. Okay. Now coming to wind energy, which is also a very good renewable source of energy. Traditionally, wind energy is harnessed by windmills to do some mechanical works. स्टूडेंट्स अपने देश में और अपने हरियाणा, राजस्थान जैसे एरिया के अंदर रहट होता था पानी के किनारे, जिसे पवन चक्की की मदद से उस चैनल में से, उस पानी के उस चैनल में से, उस छोटी सी कैनाल में से पानी निकालने के लिए काम में लाया जाता था। और जो शुगर केन का जूस निकालते थे, जिसके लिए या तो कोहलू के बैलों की तरह, जो कहते हैं ना, उदाहरण देते हैं कोहलू के बैलों की तरह काम करना, यानी सुबह से शाम तक काम करना, तो वो जो कोहलू था उसे बैलों की मदद से भी चलाया जाता था, जिसके अंदर आपके शुगर केन का जूस निकाला जाता था और जैगरी, दैट इज़ योर गुड़, उसे बनाया जाता था। It was also done with help of this wind energy using this windmill. Now, causes of wind. What causes wind? Fast moving air is known as wind. Wind possesses kinetic energy which depends upon the speed of the wind. Solar energy is responsible for blowing of wind. Air movement is generated due to unequal heating of land mass and water bodies by solar radiations, and it causes wind to blow. Now, what are the advantages of this wind energy? Wind energy is freely available in nature. There is no running expenditure to it, only installation cost is there. Wind energy is environment friendly, causes no air pollution, no sound pollution. Wind energy is a renewable source of energy, inexhaustible in nature. Wind energy is an efficient source of energy, and technology for harnessing this energy is very simple. As you can see in the figure, there are blades which are rotated with help of wind, moving high-speed wind, and an electric generator is attached with help of a shaft to these blades. This wind energy is now converted into mechanical energy by moving these windmill blades, which ultimately rotate shaft, and this dynamo, this electric generator, produces electricity. Now, there are few limitations of wind energy also. Wind energy farms can be installed only at those places where the wind speed is at least 15 km per hour. Establishment of wind energy farms requires large area of land. Installation cost is very high. Since the tower and blades of windmills are exposed to sun, rain, storm, and other physical activities, they need maintenance. Wind energy farms need some backup facilities to store energy, during which high-speed winds are flowing. Then the blades will rotate faster and more energy will be produced. Okay, now coming to some non-conventional sources of energy, such as solar energy. Now in solar energy, with one or more technological advancement and progress, our demand of energy is increasing day by day, and the conventional sources of energy like fossil fuels are available in limited quantity. Thus, we are moving and switching over to non-conventional sources of energy, which are also known as alternate sources of energy. Now in this, solar energy is the energy radiated by the sun in form of heat, light, and ultraviolet radiation. Solar energy reaching a unit area in unit time at outer edge of Earth atmosphere exposed perpendicularly to the sun rays at the average distance between the sun and Earth is known as a solar constant, and its value is 1.4 kilowatt per meter square. I repeat, the solar energy reaching a unit area in unit time at outer edge of Earth's atmosphere, exposed perpendicularly to the sun rays at the average distance between the sun and Earth. It is known as solar constant and its value is 1.4 kilowatt per meter square. It means that on an average, approximately 1.4 kilojoules of solar energy on per square meter of Earth outer layer is being given by the sun. Most of the UV rays are reflected back by the ozone layer of Earth. The sunlight, this solar energy is responsible for photosynthesis process, which is useful for the mankind. And this human being race is utilizing solar energy for various purposes, such as traditionally it is used for drying food grains, for drying fishes, firewoods, for drying clothes, obtaining salt from sea with help of evaporation. These are few examples. But in modern days, modern devices designed to harness solar energy are available, such as solar cooker, solar water heater, solar pumps, solar furnaces, solar cells, etc. Today we will discuss three of them: solar cooker, solar water heater, and solar cells. Now, what is a solar cooker? It is a box-type structure which is installed and painted black inside. It is covered with a glass plate so that heat energy should not escape and maintain and increase the inner temperature of the chamber. And the food which is kept in this cooker inside a container in the box where the temperature rises up to 140 degrees Celsius, the food is cooked. As you can see in this figure, 4 containers are there and a plain mirror which reflects the sun rays towards this box, which is closed by the lid, and lid is of plain glass. When this lid is closed, the temperature goes on increasing due to solar radiation, solar energy. This thermal energy is used to cook the food, which is ultimately a solar energy, जो heat energy में अब convert हो गई है. Okay, next is solar water heater. Solar water heater has an installed box painted black inside with a system of copper tubes. These tubes are covered with glass plates which allow heat to enter inside and does not allow heat to escape out. Same in the case of solar cooker, where the plain glass plate acting as a lid doesn't allow heat to escape. When water flows through these tubes, they absorb heat. You can see these blue color tubes, these are actually glass tubes. When water flow through this tube, it is heated up due to the heat energy of sun, and hence hot water is obtained. The next one is solar cell. Solar cell is a device which directly transforms solar energy into electrical energy. Silicon is generally used for making solar cells. It is a tetravalent element which behaves as a semiconductor. By incorporating controlled but small quantities of impurities, pure silicon, we prepare two types of silicon, which is N-type and P-type. N-type semiconductor and P-type semiconductor. In solar cell, a very thin layer of N-type semiconductor is laid over a wafer होता है बहुत पतली layer of P-type semiconductor. This thickness of N-type semiconductor is 0.3 micrometer and the thickness of P-type semiconductor is 300 micrometer. Now these small pieces of metal wires are joined to the layers of these two, N-type and P-type, and where the N-type and P-type are joined, a P-N junction is formed. P-type semiconductors and N-type semiconductors, where they joined, it is known as P-N junction. A typical solar cell, a single solar cell, develops a voltage of 0.5 volt to 1 volt and can produce 0.7 watt of electricity when exposed to solar radiation. So instead of using a cell, we use a solar panel. The electric power output of a solar cell is very small, so a large number of solar cells are combined and arranged in form of solar cell panel that can deliver enough electricity for a particular use. Now, what are the advantages of this solar energy? It is a renewable source of energy. It produces electricity. It cooks our food, it gives us hot water and does not cause any pollution. And it can be installed in remote areas where power supply is hard to deliver. Now, what are the disadvantages? It can be only harnessed if sun is present. Second thing, silicon is expensive, hence solar cells are a bit expensive. Silver is used to connecting cells, so it becomes more and more expensive. And the current produced, the electricity which is produced by the solar cell is DC, direct current, which is to be converted into AC with help of an converter, which increases further the cost of this device. Here is your arrangement of a single solar cell. You can see which is blue, it is the N-type semiconductor, and which is yellow in color, it is P-type semiconductor. The silver color which you are seeing on it is your silver, which is contact through which one cell is connected to other cell and the last cell is connected to the output from which DC output has been taken. These are the solar panels. As you can see, a solar lamp, a solar plate is attached to a bulb. Now energy, which we can harness from our oceans, from our sea. Tides, tidal energy. The periodic rise and fall of water level in sea and oceans is called tidal energy. The rise of sea water as a result of moon's attraction is called high tide, and subsequent fall in water is known as low tide. This high tide and low tide are used for generating energy, as the tidal energy is the kinetic energy of enormous power, of enormous amount of water which is moving between high tide and low tide. So by installing a tidal power plant, we can harness this tidal energy. What are the limitations of this tidal energy? There are very few sites where these type of tidal energy power stations can be installed. Cost of installation of this tidal energy power plant is high. They can only be built at seashores. It is not a continuous and reliable source of energy. The efficiency of tidal power plant is also very small as compared to other hydropower plant and thermal power plant. Now comes to ocean thermal energy. The water at the surface of ocean or a sea is heated up by the sun, but the water deep inside the ocean is relatively colder. The energy available due to the difference in the temperature of water at the sea surface and the depth of the ocean inside the ocean is termed as OTE, ocean thermal energy. Ocean thermal energy conversion plants, OTEC power plants, are installed at few places. Such a plant can operate successfully if the temperature difference between these two waters at the depth of about 2 kilometers is about 20 degrees Celsius or more at less temperature. This OTEC, Ocean Thermal Energy Conversion Plant, will not work. In an OTEC power plant, the warmer surface water is used to boil a volatile liquid, say ammonia or chlorofluorocarbon. The vapors of this liquid are then used to run the turbine of an electric generator. The cold water from the depth of the ocean is pumped up, and the condensed ammonia and CFC vapors are again converted into liquid, and thus OTEC works. Here is the tidal energy plant. You can see when valve is open, the ocean water, that is the high tide, comes rapidly inside, which rotates the turbine blade and hence operates the generator, resulting in the generation of electricity. And here is your seawater energy. When sea waves comes inside, they run the turbine, and when they leave back, they again run the turbine in opposite direction. As you can see, this yellow line, it is the construction of the powerhouse in which the seawater is frequently flown inside and outside. When it is flown inside, it produces the air to compress, which in turns rotate the turbine inside and produces energy. This is ocean thermal energy. As you can see, the cables, the cold water and the hot surface water, the temperature should be 20 degrees Celsius. These moving cables are filled with ammonia or any CFC. Then this ammonia is heated up by this hot water at the surface of the ocean. When it vaporizes, it pushes the blades and rotates the turbine to produce electricity, and when it flows through this pipe, it condenses and again becomes into liquid, and hence OTECs are working. Now there is a geothermal energy. Geothermal energy is that energy which is in the earth crust in forms of molten rocks or magma. The magma moves up, जिसे आप ज्वालामुखी भी कहते हैं. The magma moves up and collects below the earth's surface in hot spots. The underground water which comes in contact with these hot spots get heated up and produces steam at high pressure. By drilling tiny holes, holes की length large होगी but thickness will be small. Into these hot spots, the steam which comes out from these holes can be used to rotate turbines and to produce electricity. Here is a geothermal power plant in which you can see the red color is your molten magma and this dark color is your water. A red pipe which is a drill hole. Now this steam will be escape from this hole and which will result in the rotation of the turbine. Now there is nuclear energy which is also used these days at a large scale. Energy obtained during sufficient or specific nuclear process. Nuclear fission and fusion are two types. We are discussing about nuclear fission first. Energy obtained during specific nuclear process, that is nuclear fission, due to conversion of small fraction of mass into energy is called nuclear energy. Energy mass equation was given by Albert Einstein. You all know E is equal to mc square, where c is the speed of light. In nuclear fission, it It is the process of spontaneous splitting up of nucleus of heavy atom. Let me show you the diagram. As you can see, there is a nucleus of a uranium 235 which splits into two halves and three neutrons are also produced. It is a process of spontaneous splitting up of nucleus of heavy atom, say uranium 235 or plutonium 239 or thorium 233, into two lighter nuclei, along which releases a large amount of energy. Generally, it is 200 mega electron volt when bombarded with a low energy neutron. It is found that fission of one nucleus of uranium 235 atom produces 10 million times energy that is produced by the combustion of an atom of carbon from coal. 10 million times more efficient than coal. The energy produced in nuclear fission process is called nuclear energy, and it is a chain reaction. As here you can see, when you bombard a single neutron on a uranium 235, a krypton and a barium are produced, and three fast moving neutrons are again produced. Now these three neutrons, they will strike three uranium atoms. Again, from each uranium atom, three again neutrons will be dissipated, and these will be so on. This bombardment will be so on, and it should be controlled. Then it is controlled in nuclear reactors, and if this energy is uncontrolled, it becomes a nuclear bomb, also known as atom bomb. Second one is nuclear fusion. In nuclear fusion, two nuclei combine together to form a single nuclei. Again, the heat energy, tremendous amount of heat energy is released by the combination of two atoms. Now, what are the advantages and disadvantages? Advantages is, first of all, it is a clean fuel. No environmental pollution is there, no sound pollution or air pollution is there. The energy produced is very high in very less amount of fuel. Very high energy is produced. And what are the disadvantages? Cost of installation of nuclear reactor is very high. Availability of fuel, that is the uranium, plutonium, this is very limited. Nuclear reactor produces harmful nuclear waste, which is difficult to decompose. No doubt it produces clean energy, but the waste which is produced by it also radiates the harmful radiations which are responsible for different types of cancers. So here is nuclear fusion, where two deuteriums combine together to form a helium and a neutron. Here you can see two deuteriums, a deuterium and a tritium. They are bombarded together, they combine together to form a helium, neutron, and high amount of energy is being released through it. Okay, with this we come to the end of this topic. Thank you and have a nice day.